we are going to solve difference equation using Z transformation, right? Inverse Z transformation. So for that, working rule. So how to find the solution of a difference equation? So first, aim is to find yn, where zyn, which is equal to f of z, that implies yn is equal to inverse z transformation of f of z. Second one, apply z transformation on both sides of the given difference equation. Right? First, we need to apply z transformation on both sides of the given difference equation. Then third one, use the following formulas. So use one of the formulas, whatever you need for that particular problem. So zyn plus 1, which is equal to z of f of z minus y naught, or zyn plus 2, which is equal to z square f of z minus y naught minus y1 by z. Zyn plus 3, which is equal to z cube f of z minus y naught minus yn by z minus y2 by z square. Then fourth one, use the given initial conditions and simplify to get f of z. So in the problem, they will give the difference equation with initial conditions. So apply initial condition, then simplify, you get f of z. Then you apply inverse z transformation on both sides to get yn, because yn, which is equal to z inverse of capital F of z. If you know once f of z, then you can apply z inverse to f of z, you will get yn. Then solve the inverse z transformation. You know the formula for inverse z transformation. So otherwise, if it is possible, you can use the formulas. Otherwise, you can solve. You can use partial fraction method, residue method, convolution method, whatever the method you know. So you can solve, right, that inverse z transformation to find yn. Finally, we will get yn in terms of n, which is the required solution, right? That is the working rule. Based on this only, we are going to solve the difference equation. So we are going to find the solution of difference equation. So notations, yn, sometimes they will use y of n, yn plus 1, y of n plus 2, etc. etc. The y naught is nothing but y of 0. y1 is y of 1, right? Now next problem. Solve the difference equation yn plus 1 minus 2yn, which is equal to 0. Given that is the initial condition, y of 0, which is equal to 3. We'll see the solution. Given equation yn plus 1 minus 2yn, which is equal to 0, and the initial condition y0 is equal to 3. That is equation number 1. Now apply z transformation on both sides of 1. So yn plus 1 minus 2yn, which is equal to z of 0. So separating zyn plus 1 minus 2 times zyn, which is equal to z of 0, 0. That is equal to 0. Right? Now z of f of z, we know the formula. So z of yn plus 1, which is equal to z of y f of z into f of z minus y naught, minus z of yn is nothing but f of z, capital F of z, which is equal to 0. So we know the formulas, we are applying that formulas. Now z into f of z minus y naught, they have given in 1, y naught is equal to 3, right? So minus 3 minus 2 into f of z equal to 0, right? Now z f of z multiplying with z f of z minus 3 into z minus 2 f of z equal to 0. Now grouping f of z. So first term z and the last term minus 2, z minus 2 f of z, which is equal to, taking that minus 3z to the other side of the equality, you will get plus 3z. Therefore f of z, which is equal to 3z by z minus 2, come to the denominator of the right side. So z minus 2, 3z by z minus 2. That is equation number 2. Now taking inverse z transformation on both sides to find y of n, right? yn. So taking z inverse of f of z, which is equal to z inverse of 3 into z by z minus 2. So taking 3 outside, so we know z inverse of f of z is yn, which is equal to 3 into z inverse of z by z minus 2. We know the formula. Z inverse of Z by Z minus A, which is equal to A power n. Instead of A, you are having 2, so it can be written as 3 into 2 power n. So y of yn, which is equal to 3 into 2 power n, is the required solution for the given difference equation.